this way.
Okay, so we'll have a class today. We'll move on to the next chapter. We'll talk about lipids. And the key thing is for the lipids oxidation. That's as important as like a Maillard reaction. But today we're going to give you the introduction of lipids and give a very brief introduction about triglycerol. And then next week we'll move on to that section. So this is we're going to talk about lipids. So first of all, what is the definition of lipids? That is a tricky question, and the scientific area spending lots of time to find a good definition. And in our textbook, which is mentioned, the best definition is chemical compounds can be dissolved in organic solvent. So for example, let's say something if can dissolve in alcohol, then we can say it is a lipids. However, they say except monoglycerides and short chain fatty acids, because they think these is water soluble. So let's say we talk about acidic acids, we talk about propionic acids, even formic acids, those can be dissolved in the water. So this definition is not really completed, but the best definition what we can have. Okay, so that's the first question. Second question, we gave you a very easy example. If in a food products, we know there is basically two types of lipids, which is fat, that is a solid status, everybody knows. And also could be an oil, which is a liquid status. Now we're going to move on to the next question is what's the function of the lipids? Now before that, I also want to review really quick. We also could be separate them into non-polar and polar. So non-polar, we have the example like triglycerols and cholesterol. And the polar lipids, we could say phospholipids. And we mentioned a couple of times in different classes you already learned that is head, which is hydrophilic, and tail is hydrophobic, and we have another name for hydrophobic. We call it lipophilic. That's we use a quotation mark because it's just people make you understand, so they write like that. Okay, the next question will be, what is the function of lipids? This is, everybody knows, it is could be a stabilization of a food products. It could be an emulsification of a food products. And it could be, we mentioned it could be an interaction, and it also could make some modification. Because of that, the lipids gives a food product sometimes a unique aroma, a taste, and a texture, and give them nutrients, and very important, we talk all the time, give you energy. Although from the dietitian standpoint, we want to control the lipids, but they do give you the energy. And also, there is a research showing that the lipids amount is important to manufacturing, which is hormone by the body. So appropriate amount of the lipids is important. Now next we also want to say in the food products, we had lots of the time, we can see the lipids. So we say it's visible. So we gave you some of the example. Let's say if it's a fat from pig, swine, or hog, we call it a lard. And it is actually a very good material to making the Chinese foods or some Asian style cuisine. They're using a lard. Now, same thing, if it is coming from cattle or beef, we call it a tallow. And that is usually we call it a natural fatty acids. But we also can manufacture some. For example, margarine. That we're going to talk all the time, and also the shortenings. That is manufactured as fatty acids products. People say it's not healthy, but from the other standpoint, it is solved the problem of food security in a certain period of time. Now, visible fatty acids, usually it is about 40%. So surprisingly, even we see the fatty acids there, it is not the vast majority. Now, vast majority, it is invisible fatty acids. That is about 55 to 60%, roughly 60%. So we don't have example, but I want to tell you, even fresh produce, fruits, you're not going to feeling any lipids there. How many amount? Sometimes 3 to 8% of the fatty acids are there. You won't even see it. So that's visible versus invisible. Then the next category, we could categorize the resource of lipids. So we say it could come from animals. So animal fatty acids. The animal fatty acids obviously could come from depot fat. And this is we already talked about, like lard, like tallow. That we already know. And it's obviously you can see it. Second one, it is coming from milk or related dairy products. Okay, then where that come from? That related to another big topic, which is microorganism in rumen or ruminant nutrition. We can say ruminant nutrition cycle of cows. It's a big topic, and there used to be Dr. Fallon and Dr. Marie Krause, they do lots of the research about that. It's a big topic, it's very interesting. Next one, we mentioned lots of time, is marine fatty acids, or we say marine oil. That is coming from, basically is fish. So fish oil. And we also call it's like a deep ocean fish oil. What we really care about would bring us interesting, which is EPA and DHA. Okay, now, what is EPA? This is not Environmental Protection Agency. If you look at the news all the time, EPA is Environmental Protection Agency. It's not. What's the full name for that? That's called eicosapentaenoic acid. We're going to talk about that later. Okay, just give you an example. That's EPA. Now, what is that? It is carbon 20, comma 5, and delta 5. So that could be writing as cis 5, cis 8, cis 11, cis 14, and cis 17. There you go. Ecosa, penta, ionic gases. That's EPA. Now, what is DHA? This is not dihydroalanine. We mentioned the amino acid reaction. By the time we talk about dihydroalanine for the cross-linking, it is not. So what is that? This is penta. Sorry, not penta. Hexa anoic acid. So what is that? This is C22 6 delta 4. So what is going to be? That will be cis 4, cis 7, cis 11, cis 14, cis 17, and cis 20. Okay, just give you some hints, and we are going to talk about that later. Now, why we say these are important? Because there's a lot of research say EPA and DHA, they could be decrease horrible fatty acids, which is LDL, in the blood vessel, in the bloodstream, and could be prevent cardiovascular disease. Okay. But what's the challenge for that? This is coming from the deep ocean. Deep ocean, if you see some of the environmental reports, they are contaminated with mercury. It is contaminated with mercury a lot. So, how are you going to remove all those mercury contaminants? It's actually a challenge. Now, lots of the products more or less have some. So, if you buy a bottle from the CVS or from the, we say it's a GNC, you see the bottle, they always say, a state-of-the-art technique to remove mercury contaminants. We have a fish oil. That's the reason, because it's actually the mercury contaminants a lot, and those heavy metal is very difficult to remove. Okay, so this is give you something to talk about the animal resource of the fatty acids. Then we have vegetable resource of fatty acids. This is some example we obviously know. It's could coming from seed. Let's say soybean oil. Let's say sunflower oil used for cooking. It also could come from the surface, so skin surface. Let's say you have olive oil. This is not usually for cooking, for dipping. And it also could come from the kernel. Let's say you have a coconut oil. Coconut oil. Okay, that's from the vegetable resource. That's why we mentioned the vegetable, even you didn't see anything showing like a lot of taro, there's the fatty acids, it actually has a lot. And basically at least 3 to 8%. Okay, so this is just give you some opening remarks and give you some of the introduction. Now we want to talk about is the fatty acids. So we want to talk about here is fatty acids. And we're going to just use acronym FAS to talk about it. So what is fatty acids? We won't go detail, but just give you an example. We just draw something. Just draw a couple, okay, I don't know how many. So what is that? Here is all CH2, CH2. So what is fatty acids? We always say long chain, and we just make quotation mark, okay, maybe a short chain. A chain or a long chain of CH2. What is we call it? This is we call it a hydrocarbon with two ends. What are the two ends? That's very important. CH3 with methyl end and COOH. This could be writing like this. We mentioned a couple of times. And the carboxy ends. We will talk. These two ends are extremely important. When we talk about nomenclature, these two ends are important. So we want to highlight here. Okay, so that's what is a fatty acids. Now, lots of the time when we talk about fatty acids, it's natural fatty acids. Natural fatty acids, most of the time, it is about 14 to 24 carbon. With the dominant is 16 to 20 carbon is a dominant. Now the natural fatty acids, most of them is even number of CH2. Or we just say even number of carbon. Why? Because every time you add it, you are adding 2 each time. And 90%, more than 90% is even number. Do we have an odds number? Yes, we have some. Where it comes from? Most of the time, microorganism. So microorganism is always very special. And where the other comes from? Dairy products. Now dairy products, it's also coming from microorganism because we mentioned about luminant reaction, luminant nutrition. Okay, so that's a natural fatty acids. We want to talk about the natural fatty acids, so we move to the top. We just gave you some of another introduction of fatty acids. We know they could have two major categories, which is saturated versus unsaturated. And the saturated could have, we call it short chain fatty acids, and the medium chain, medium chain fatty acids. Make sure the spelling is good. And also the long chain fatty acids. Now, what is the difference between saturated and unsaturated? And everybody knows. Saturated, there is no double bonds. Unsaturated, it more or less has at least one double bonds. So saturated fatty acids could have a short chain, medium chain, and long chain. Short chain usually carbon 4 to 10, and the medium chain usually carbon 12 to 14. And if you have a long chain, it's carbon 6 above. That means it's a long chain. Okay. Now unsaturated fatty acids, based on the rotation of the double bonds, we could categorize them as cis and trans because of the rotation. So you can say, I just draw some. Let's say we do like this, and then we're going to do another one. It is actually could be on the top. Okay, I just draw a demo. Well, not really true. Okay, we're going to have an example later on. So cis and trans. So we're going to move on to the talk about the fatty acids, and we first of all want to give you some of the examples of the short chain fatty acids. Okay, so we want to talk about this guy first, which is short chain fatty acids. So what are the short chain fatty acids? Number one, what is the easiest and the shortest fatty acids? HCOOH. What is this? Formic acid. Where is formic acid comes from? Originally coming from an ants. So it's from the ants' venom. It is used for the protection. It's a chemical for them to defend the enemies, because they say this will be killing a bacteria, parasites. So the formic acid is the easiest one. The second one we pretty much know about, CH3COOH. What is that? Acetic acids. Now where is acetic acids comes from? It is coming from a vinegar. This is actually we call it a double to triple fermented products. What is the components usually? The percentage of acetic acids in vinegar is roughly about 5%. If you buy a bottle of apple vinegar or like vinegar water, usually 5% acetic acids. It's antimicrobials. Obviously, we know that. Okay, and we mentioned the vinegar, the acetic acids could cause the denaturing of the egg white, then will be contribute to the egg mayonnaise, which is a gel formation. We just mentioned that because finally you have a dropping lids of those egg whites there. Okay, so acetic acids. Next one, we mentioned a little bit longer, going to be chain. So that's going to be CH3, CH2, and then we go COOH. What is this? Probionic acids. Okay, we want to make sure the spelling is good. Propionic acids, sorry, not bionic, pionic acids. Where is this comes from? This comes from probionic bacterium. It's coming from a bacteria. Then where is this one usually existing? I should use yellow color. I'm going to draw something like this. Where this comes from looks like Swiss cheese. And the Swiss cheese, you see those holes there, which is carbon dioxide through the hormone fermentation. Because it's generated probionic acids, and the bacteria specific for that during the fermentation is probionic bacteria. Okay, so that's probionic acids. Now, let's make the chain a little bit long. CH3, CH2, CH2, COOH. Now you have a 4 carbon there. What is this guy? Butyric gases. This is very interesting. During the dairy fermentation and manufacturing, this is contribute to the butter flavor for some of the cheese products. And there is a human nutrition research has been done. If the butyric acids add sodium there, becomes sodium butyric acids, we can treat it as a functional ingredients because it will be promote the calcium absorption of bone So basically it will be promote the bone formation and the development of the bone structure related to collagen. Okay, so that's lots of the research talk about that. So we mentioned these are very short chain fatty acids. We're not going to mention everything because that's a long way to go. Next, we want to spending some time talk about a very important topic, which is called nomenclature of fatty acids. Okay, yeah, just move it to the, just move it gently to the exactly on the center. Okay. Yeah. Yeah, that's good. Nomenclature of fatty acids. What this means? This means how we name fatty acids. Now we name these fatty acids. You see a different textbook and in different classes. It's different resource. Sometimes it's even a little confusing about what are they really means. So in Dr. Fenneman's textbook, I think it's described very well. We were using, coming from IUPAC. What are they? This is called International Union of Pure and Applied Chemists. So coming from this union, which have the three different categories for how we name, how we do nomenclature of the fatty acids. Each of here, I is international, U is union, P is pure, A is applied, C is chemists. So basically they have three different categories. The first one is we call common name. That's the first one. Then on the left side, it's called systematic number. On the right side, it's called numerical abbreviation. Okay. This, we wanted to talk about several things. We mentioned formic acids, acetic acids, propionic acids, and butyric acids, which is until carbon 4. So we're going to jump some. We're not going to talk all of them. We're going to move on to carbon 10. So let's do this one. C10, 0. So what does this mean when you see this? Right. This means it is a 10 chain, 10 carbon chain. I shouldn't write CH2, I should say it's 10 carbon chain, saturated fatty acids with no, we just say 0 double bonds. That's what the C10O means. Now, what's a common name for that? The reason is not everybody is a food chemist. That's called capric acid. Okay, what is a systematic number for that? We already gave an example of EP and DHA. The systematic number is decaonic. DEC, which means 10. Now, originally, this should be right. Decon. That's very easy, which means capric acid. Now they change the E becomes OIC, which stands for COOH, carboxy ends. So that's the first one. Okay. Now let's skip some, move to the next one. Let's do C16 0. So let's only have a C16 0. Okay, so here you already know 16 carbon, saturated fatty acids, no double bonds. When you see C16 0, what's the common name for that? Palmitic acids. This is a really bad acid. It's from palm, using for cooking. If you don't know, did you ever go for Florida? There is a Palm Beach County on the very south side. So Palm Beach at Florida. So you can remember that. It's palmitic acids. 16 carbon, no double bonds. What is the systematic number for that? Since this is already 16, so how we say 16? Hexa, deca, ionic acid. Okay, hexadecaonic. Now let's talk about next one. C18. This is, we know, 18 carbon, saturated fatty acids, no double bonds. What's the name of this one? We all always know this. Not good one. Stearic acid. Had in the taro, in our cooking oil a lot, stearic acids. So what's a systematic number for that? It becomes 18. So how are you going to say it? That's called octa deca ionic acid. So these three are very common saturated fatty acids. We gave you the example. Okay, how about unsaturated fatty acids? Let's talk about that. The first one, you're going to write C18, 1 delta 9. Okay, it's a little bit of difference. How we say it? It is 18 carbon unsaturated fatty acids with 1 double bonds at carbon 9 from carboxy ends. That's what it comes from. What's the common name for that? Oleic acid. Okay, now how are you going to write that? Since it's become unsaturated fatty acids, so you're going to have to write cis 9 octa deca. Now we're going to change it. Enoic. Once you see ENOIC, which means it's an unsaturated fatty acids. So that's oleic acids. Now let's make a little bit difficult one. C18, 2 delta 9 and delta 12. This is very interesting. It's always 3 carbon distance interrupted with a methylene group. We'll show you real quick. Okay, what is this? This is 18 carbon unsaturated fatty acids with 2 double bonds at carbon 9 and carbon 12 from carboxy ends. Okay, what is the common name for this one? Linoleic acid. Now how are we going to write here? Since it's a 2 double bonds, so we're going to say cis 9, cis 12, octa, deca. Now you're going to have a difference. Dianoic gases. Anoic. Okay? Okay, let's do last one. C18, 3, delta 9, delta 12, and delta 15. Now what is this? 18 carbon unsaturated fatty acids with 3 double bonds from, the first one starts with carbon 9, at carbon 9, carbon 12, carbon 15 from carboxy ends. Okay, what is the common name for this one? Linolenic acid. Okay, you can do this by yourself. This will become cis 9, cis 12, cis 15, octa, deca, then you're going to change trianoic. And you can do a quiz if your instructor how to write the full name of EP and DHA. Because that's a very good question. And then you can ask them what is the biological function of EP and DHA and do a little bit of literature search. Okay, that's a very good question in the exam. So here we basically finish the section, which is we talk about the name of fatty acids. And you learned in your biochemistry class and chemistry class a lot, but we just gave you several examples from carbonic acids, palmitic acids, stearic acids, oleic acids, linolenic acids, and linolenic acids. Linolenic acid and linolenic acids. Give the example. Then we want to move on to another thing. So remember, okay, this is a carbon. Doesn't mean how complicated it is. All these are named from COOH, carboxy ends. How about this ends, the methyl ends? We haven't mentioned yet. Now, if you look at all those products, what they tells you, I had a very magic biological function products, oil, which is we call omega-3. And I have another magic one, can prevent heart disease, recommended by American Association of Heart Health, whatever they call, omega-6. Okay, what this means, that is another name structure, which is coming from the methyl ends. So we're going to explain that to you. Okay, we want you to understand about what it is talking about. So let's talk about that. Let's go ahead to do is linolenic acids. So we're going to have to draw it. So we're going to cut from here. I'm going to explain to you. Linolenic acids, we already say about that. And lots of the time, people can write another way, which is 18, 2N6. Okay, where it comes from? That means 18 carbon, 2 double bonds started from N6. That N6 is a numerical number coming from the methyl ends. So what it is? Then we're going to have to draw the structure of linolenic acids. Okay, this time we have to draw seriously. So go top, here, go here. 1, 2, 3, we'll go here, COOH. What are we missing there? Double bonds. So add double bonds, add double bond. Okay, now we're going to have to name. We're going to put a number there. So how are we going to do it? Carbon number 1, number 2, number 6. Okay, sorry. I need a one more. It's missing one there. There is 2. CH3 up. Okay, so that's CH2. That's CH2. And that's CH2. And the I'll just skip it. So let's name it. 1, carbon number 2, number 3, number 4, number 5, number 6. Okay, you see it? And then number 7, number 8, number 9, number 10, 11, 12, 13, 14, 15, 16, and actually you're going to have another one. 17 and 18. So, you go other side. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that right? That's 10, 11, 12, 13. Okay, if you go other side. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. That should be start from 9. So did I miss in 1, 2, 3, 4, 5, 6? Sorry, I made a mistake here. I made a mistake. That's 7. Okay. I forgot about how to count. 7, 8, 9, 10. Then you have 3. 1, 2, 3. Okay, so that's 11, 12, 13, 14, 15, 16, 17, and go up here is 18. So you go back 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's correct. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you go 10, 11, 12, 13, 14, 15, 16, 17, and 18. So, from that side, it is delta 9, and that's delta 12. And from here, it starts from 6. So that's why we call it omega 6. So, if you want to write a full name about that, what we call, it is 18 carbon unsaturated fatty acids with 2 double bonds. The first from carbon number 6 from the methyl ends. And we should say this is at. This is not from. This is at. Okay, that is means omega 6. What that means. Now you can see that every time this is around like a 3 carbon distance, and we call this is interrupted with methylene group. So it's always like 3 carbon distance with the double bonds. Okay, that's omega 3. What is that's omega 6? What is omega 3 means? So we finished talking about this. We're going to talk about that one. That we have to using an example is linolenic acids. So we could draw right here. Linolenic guess it. Okay, what is that? We can write 18, comma, 3 and 3. And that we call omega 3. So let's draw that, what it looks like. This will be CH3, go down, up. Okay, go 1, 2, 3, go down. And then let's count that one. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. The last one goes here. It is 18. Now where is the double bonds? Right here, and right here. And that's the same thing interrupted with methyl group. Okay, now let's do the other way. Let's call it number 1, number 2, 3, 4, 5, 6, 7, 8, 9. That's correct. 10, 11, 12, 13, 14, 15, 16, 17, and go back is 18. So omega 3, if you want to write a full name, that is 18 carbon unsaturated fatty acids with 3 double bonds. First at carbon number 3 from the methyl ends. That's another question you could ask your students about it. What the omega 6 and the omega 3 means. Okay, that's we solved the problem right here. Now we also want to say, either for the chemistry area, we talk about chemistry a lot, but does not make everybody clear about it. And we want to make their life easy, so how we do? We call it a short ends, we want to make sure, shorthand description. We call it a shorthand description. So how we do that? We just say 18, 0, that's stearic acids. And we just say 18, 1, not even mention anything. We call it oleic acids. And we also say 18, 2, linolenic acid. Now sometimes we add a cis-9 there. Sometimes we add a cis-9, cis-12 there, bracket. But we just write like that. This is usually in the manufacturing areas, they just use shorthanded description to describe that. So this tells you there's a different way we could explain it with different purposes. This is from for chemistry. This is usually from different ends, which is from the methyl ends, and we also could do a shorthanded description. Okay, so this is something we want to mention about that. Okay, then we want to talk about is one scenario always happen. We will be using oleic acids as an example. So what is oleic acids? Okay, oleic acids everybody knows already. C18 delta 9. 18 carbon, 1 double bonds. Unsaturated fatty acids start from 9 position from the carboxy ends. So let's just draw it. Okay. CH3. We just draw. COH. Let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17. Okay, I have a double bonds right here. This is called alkene. This is we call cis configuration. Okay, lots of the time, what will happen? This double bond is gonna go to the top. Sorry, I should have write on the top. Then we go down. So cis, let's just write on the top. Right on the top. Okay. That's just cis. Okay, so let's try it again. CH3, go down, 3, up, 1, 2, 3. Okay. This double bond all of a sudden goes down. From top, moves down. Becomes alkane. This is called trans configuration. Why this will happen? This is happened actually by the people doing the chemical manufacturing. There is a process called hydrogenation. So let's talk about that, what it is.
I thought that the hydrogens were on the opposite side of the double bonds.
Trans on the top?
No, like for the trans, I thought that the hydrogens are on the opposite side of the double bonds. So like in cis, the hydrogens are on the same side as the double bond, but the trans are on opposite sides.
So how are you going to draw?
It would just be diagonal. You don't make it, just keep it diagonal and just add a double bond.
Okay. That's fine. I'll just draw like that. Easy to understand. That's on the top, that's on the bottom.
But that's not accurate because the trans...
Can you draw it?
Yeah.
Go ahead, guys. Yeah, you just remove it, right?
No, you're good.
Very simple. How are you doing?
Yes.
Hey, don't be nervous, just try. Oh, you want to do like this?
Yeah.
Oh, okay.
2 hydrogens.
Okay, that makes you comfortable. That's fine. Okay. Alright. So you'll be here, I'm right on the top. Okay. So that means this is gonna be that correct? Like this? That's on the
No. Yours, the cis is fine. Your cis is good.
So the trans, okay. Cis is good.
Cis is good. Trans, yeah,
Cis is like this.
correct.
This is gonna be here.
Yes, because your hydrogens are on the opposite.
Okay, so that's good. Thank you. Okay, so let's talk about that. What has happened? This is called hydrogenation, the process. This is in 90s. People made fatty acids, unsaturated fatty acids to the soap. Okay, it's the first time people find it. Then 1960s to 1980s, people do this a lot. Because why? They want to make some of the manufacturing shortenings. Okay, how they did that? This is usually unsaturated fatty acids at a very high temperature, 200 degrees Celsius heating. And then you're going to do a bubbling of hydrogen. You keep bubbling there. And we want to let this reaction happen more quickly. What they do, they add nickel as a catalyst. So then what happens is this will become trans. Now, this is not the purpose to do it. They want to make unsaturated fatty acids become saturated fatty acids. However, you know the biochemical organic chemistry reaction is not 100% completed. It is reversible. And then they generate intermediate products, which is from cis to the trans. So this is actually an intermediate product. Now, why this will happen? Because from energy standpoint, This is more stable. And then these shortenings generate. What's a good thing for these things? This is much stable. What this means, long shelf life. And less oxidation happens. And less rancidity. So, these products are generated a lot by the 1980s. Even some of the bread, they do like that. What the problem is solved, we just mentioned. It's solved the problem, food security. So when you live in the poverty, the food supply is important. So we talk about food security by the time. It solved the problem. However, the research has been found, if you have the trans fatty acids, it's very difficult for the liver, for the enzyme to break it down. Because the melting point is much higher than cis fatty acids. Okay, that's an intermediate product. So that's a story about that. Now, we talk about the food security. That's why these days we mention about food security. We talk about affordable. We talk about the food safety. And we also talk about the nutrition. And then all these things we come together. We talk about sustainable food system. Okay, that's what it comes from. Okay, this is pretty much what I have, but I left some time. I want to mention one very important thing, which is talk about the melting points. We just do some of the conclusion. We're going to write here. Okay. For the melting points. This is a very important concept. Usually talk about manufacturing. We should know. I'll just write low and high. It is a common sense, but we just want to talk about that. Melting points, basically, unsaturated fatty acids is lower than saturated fatty acids. Short-chain fatty acids have low melting points compared to long-chain fatty acids. And cis configuration fatty acids has lower melting points compared to trans. And we also talking about there are some theory which is the cis fatty acids, they could causing a curvature of those fatty acids. And they will be prevent the crystallization generate. So that's why the melting point is basically is lower. Okay, so that's something we want to talk. Okay, these are we finished talk about fatty acids, and on spring break, after spring break on Tuesday we will talk about triglycerides. Okay.